Hello student, welcome to our second lesson on electrical conductivity of molten substances. Meaning, if it is molten, then a source of heat should be provided. The arrangement of apparatus used to investigate the electrical conductivity of molten substances consists of two solid conductors, each with an end dipped into melt under investigation. So we will have the two conductors, and then we have molten substances. Then to the other end, each solid conductor is connected to a source of direct current, and this one will be indicated in the diagram. The two solid conductors are called electrode. The electrode connected to the positive terminal of the battery, it is good to note this, are called the anode, and the one on the negative terminal of the battery is called the cathode. So this one is usually negatively or a negative, where this one is positive, which is called the anode. The graphite rods are frequently used as electrode because they are non-reactive and cheap. It is good to note that. Why graphite is used as electrode? It is because non-reactive and cheap. So here we have now this apparatus or the setup. We'll have the two electrodes. These are made of graphite, and these are the ones that are dipped into the solid that you want to investigate. So we have, in this case, we have reed 2 bromide, and since we need it in the molten state, then we need to have the source of heat. If you don't have this one, then this one will not be molten. So we need to have this one, reed bromide in molten. Then the current will move this way, okay, in that direction, while the current, the electrons usually moves in this direction. So it is in opposite direction when the circuit is closed. So we have the crocodile clips, we have negatively charged electron. This is the cathode. If you look carefully, you'll find this electrode is connected to the negative terminal, while the anode is connected to the positive terminal. So positively a charged electrode known as anode. This is what we are explaining here. We move on. When we insert the electrodes in the solid lead 2 bromide, the bulb does not light up. So if the solid is not molten, it is in solid state, then the bulb will not light up, meaning there is no flow of current. But bulbs light up when lead 2 bromide is heated until it melts. Good to note that. This indicates that molten lead 2 bromide conducts electricity. It is an electrolyte. Metal compound in molten states are electrolyte. It is also observed that other substances like sulfur, paraffin wax do not conduct electricity when in solid or molten form. Therefore, sulfur, paraffin wax are known as non-electrolyte. So electrolyte, they conduct electricity in molten state, and they also get decomposed. An electrolyte is a substance which, when melted or dissolved in water, conducts an electric current. The definition is not complete if you don't state that it also gets decomposed by the electric current. So it doesn't only conduct electricity, but also it gets decomposed. So when defining an electrolyte, remember you have to state about conductivity in molten form or dissolved in water, and then it also gets decomposed by that current. Metals are good conductors, both in solid and molten state, because of the presence of what we call delocalized electrons. And also we noted graphite, which is a non-metal, also contain delocalized electrons in their structure. When metals are melted, the delocalized electrons remain mobile, enabling metals to be good conductors in molten state. But now, molten metals cannot be called electrolyte because they don't get decomposed. Here is a structure of the solid with 2 bromine. Ions are not free to move, so we don't have free ions here. But when in molten state, you'll find there are free ions to move. So what is responsible in the molten state is free ions to move. So in this case, we don't talk about delocalized electron as we said in graphite and metal. So the molten state, which is an ionic compound, lead bromide, then the ions are the ones which are responsible for the conductivity of the electric current. Other examples of electrolyte and non-electrolyte are given here. We have electrolyte, sodium chloride solution. It is good to note that. Then solid sodium chloride is non-electrolyte. But when it is in solution form, it is an electrolyte. Copper 2 chloride in solution is an electrolyte. Sodium hydroxide solution, molten lead 2 bromide. But solid lead 2 bromide is non-electrolyte. Then we have molten lead 2 iodide, hydrochloric acid, sulfuric acid, ethanoic acid, and most salt in molten or aqueous form are also called electrolytes. Non-electrolytes include pure water, sugar solution, paraffin wax, molten sulfur. We have solid lead 2 bromide, solid sodium chloride, and then we have ethanol or alcohol, and then we have urea, which exists as molecular form. Here is a setup to show the conductivity of substances in aqueous state. So under this one, we have the ammeter or the bulb to show the flow of electric current. Then we have the flow of electrons. The electrons will move in this direction, while the current will move in the opposite direction. So we have the connecting wires, we have the switch, then we have the graphite rod, and this one is a cathode. Why is a cathode? Because it is negatively charged, and this one is connected to the negative terminal of the battery. Then we have the solution being tested. We have the anode connected to the positive terminal of the battery. Solid chloride, sodium chloride, copper 2 sulfate, and copper 2 chloride do not conduct electricity in solid state, but when dissolved in water, they conduct. Aqueous solutions of salt, bases, and acids are electrolyte and contains mobile ions. So, because these ionic compounds, they contain ions. The mobile ions are responsible for electrical conductivity. When the circuit is completed, positive ions in the solution moves to the negative electrode or the cathode. So the positive will move towards the negative because there is force of attraction between positive and negative, while the negative ions moves to the positive electrode, that is the anode. So you'll find those which are negatively charged will move towards the anode, which is positively charged. Convectionally, an electric current is shown to move in the positive terminal through the circuit. When then the negative terminal, even when the electrons actually moves in that direction, from the negative terminal to the positive terminal. And I think this one is clearly shown in the previous diagram, that you find that the current is shown to move from the positive terminal of the battery through the circuit then to the negative terminal. Then the electrons actually from the negative terminal to the external circuit, then back to the positive terminal. The movements of ion in the solution constitute the current through the solution. Solution of urea sugar do not conduct electricity. Why? Because they are molecular substances. So urea and sugar are molecular substances. So they don't contain ions. And that is why they don't conduct electric current, because they do not contain ions. So in this case, you will have solid sodium chloride, ions not free to move, while in the aqueous state, the ions are free to move. So the ions are responsible for electric conductivity. Here the assignment for you. The answers are provided in the notes section. Read carefully, answer, and mark for yourself. Thank you and wish you the best. I hope you are enjoying our online lessons.